Okay, hopefully you've tried the answers yourself. Which number is an irrational number? Think to yourself, what is the question asking? Irrational. Cannot be expressed as two integers over each other, and if it's a decimal, it won't repeat, right? So remember, the line means repeating. So that is definitely rational, so that's definitely not going to work. -4 is an integer, so that's definitely a rational number. Here's two integers expressed as a fraction, so that's definitely not going to work. So obviously it's going to be the square root of 5, right? Because that decimal will not repeat. Set F and set G are given. So we've got F, 2, 4, 6, 8, 10, 12. Set G is the set of whole numbers that are multiples of 3. Okay? You have to pull out the information that you need. Multiples of 3. So what is 3 a multiple of? Well, 3 times 2 is 6. 3 times 4 is 12. So set G is just 6 and 12, right? These are called data sets. So select the statement that correctly describes the numbers that are common to both set F and set G. Okay, let's check. The common numbers are always divisible by 4. Well, 12 is divisible by 4, but 6 is not divisible by 4. No, that's not going to work. The common numbers are always divisible multiples of 6. Well, yeah, 6 times 1 is 6. 6 times 2 is 12. Okay, so yeah, that's one, but I'm going to read them all just to be sure, you know. Sometimes it'll even say check 2. The common numbers are always odd numbers. Well, 6 is not odd, and 12 is not odd, so that doesn't work. There are no common numbers. Well, that doesn't, no, 6 and 12 are common. So this one was easy, right? It's just B. All right, moving along. Page 2 here. Which value is equivalent to 1.2 times 10 to the 4? So remember, when you see the 10 to the 4, think to yourself, this is the important information here, the 10 to the 4. We've got to move that decimal spot over 4 places. We're moving it over. So if I had 1.2, I got to move it over. 1, 2, 3, 4. And I got to fill in with the zeros. It has to move 4 spaces. So it should be 12,000. C. All right. Select 2 expressions that are equivalent. Again, what am I looking for? I'm looking for y to the 9. Okay, so rules. These are, I need my rules of exponents. What are my exponent rules? Okay, so I know that when I subtract, or pardon me, when I divide and the bases are the same, I have to subtract. When I multiply, I have to add the exponents. If the bases are the same here, I would add these. This would be 2y. I have one y and have another y. So I have 2y to the 9. And if I'm multiplying, right, I'm going to add them up. So let's have a look. So 4 plus 5, this is y to the 9. Okay, well, yeah. But look, careful, 2. So definitely this one, okay. So we already know no, because this has a 2 there, so that's not it. We have to add these up. So this would be y to the 10, so no. And we're going to subtract. 10 minus 1 would be y to the 9. All right, so you have to make sure you're selecting them both. Next page. Okay, you're going to get some pictures like this. And it says, which option has a ratio of squares to triangles equivalent? Oh, make sure you understand what they're asking. Equivalent to 4 over 5. Okay, so you could scale it up or you could scale it down. Let's have a look. This is 3 and this is 4. I don't think that's the same ratio. This is 6. I don't think it's that one. 6 would be like if I went from 4 to 6, I'm scaling that up. 1, 2, 3, 4, 5. No, that doesn't look like it's right. I don't know. I don't think that's it. 4 to 5. 1, 2, 3, 4, 5. Oh, 8. Well, 4, if I doubled it, I would get 8. 5, if I doubled it, I would get 10. 1, 2, 3, 4, 5, 10. Oh! And let me just always check the last one too. Oh, this is 9. No, that's not going to work. 9 and this is another 10. So that's not even the same kind of right now. No, absolutely not. Okay. A recipe uses 1/3 cup of butter, 1/4 cup of milk, and 1/2 cup of flour. Okay, now you need all this information. The baker, he has 4 cups of butter. Let's do the butter first. And he needs 1/3 a cup. What is the maximum number of times that he can make this exact recipe? So let's say to ourselves, if we have 1/3 a cup of butter, and we know that the baker has 4 cups, right? So you ask yourself, well, how many times, I'm writing the answer down. If I have 4 cups, right, times 4, and then if I multiply that 1/3 times 4, how many times does it basically go in there? Is 12. Think to yourself, 1/3 cup, 3 of them would be a cup, right? So 3 of these together gives you 1 cup times 4, because you have 4 cups of butter, so I could make 12 cupcakes. Or it doesn't say, it just says number of times the recipe can make it. Okay, so 12 times. Okay, so we know that's, and we're looking for the lowest number here. Okay, now we did butter. Now let's do milk. Okay, so we need 1/4 cup of milk. And how much milk do we have? We have 6 cups of milk. So if I multiply those together, if I say to myself, how many cups do I have? I'm basically kind of like cross multiplying here. I could put that in 24 times. 6 times 4 is 24. And for the last one, I have 1/2 a cup of flour. And I have 7 cups of flour on hand. How many times does that 1/2 a cup of flour basically go in? That's what you're asking. It's like, how many times does that 1/2 cup of flour go into the 7? Well, I can put it in there 14 times. What's the smallest one here? 12. Okay, so there's a couple ways you can think of that one, but that's how I think of it. I think, all right, I have 1/3 cup of butter, so I could do 3 times to get 1 cup. 3 times 4 is 12. All right, next one, moving along. What is our simplified version using algebra? This whole class was so much algebra, right? And you can bring a scrap paper and pen in. You're allowed to, right? So x squared minus 3x plus 2. This is distributive law, right? So you know 2 times x is 2x. I'm going to have 2x, but look, I have to add them. Remember, you have to add them because you're multiplying. So I actually have 2x to the power of 3. Then the 2x gets distributed over to and this all goes together, to the minus 3. So I have negative 6x. I have 1x there. I have 1x there, squared. Then the 2 goes over to this 2. 2x plus 2 is plus 4x. And I still have an x there. So let's see if I have that answer. Do I have one that is 2x squared minus 6x plus 4? You bet. Okay, so that one I would work it out. In a game, our participant moves a game piece around a board. The participant will receive 100 points. So 100 is going to go up, right? You're going to get 100 points if you land on the blue piece. So I'm going to say you get 100 points from every blue piece that you are hitting. But you are going to lose 50 points if you land on a yellow piece. So I'm going to lose minus 50 points if I land on a yellow piece. Let's see if I have something that looks like that. Yes, I do. Another B. Right? So again, work it out. Use your highlighter. Think to yourself, what are they asking? What do I know? What don't I know? And you can flag questions and come back to them in the program. Oh, I love this question. Okay, you're going to have to do some more work here. Let's think. you have got a couple of different shapes. Now, you can't just do this all at once. So here's what I did. I'm like, all right, I'm going to do this as 2 rectangles. So I'm just going to draw a line. Basically, I'm going to have like rectangle 1 and rectangle 2, right? Because I have to figure this out. So in rectangle 1, I know that I have to figure out the area is just length times width. 4x times 7x plus 1, right? That is going to be my first area. All right. Distributive law, 4 times 7 is 28. X times x is x squared. Distributive law, because remember this plus 1, it was like this is kind of like an island and this is kind of like an island, right? 2 things. 4x plus 1 is then just plus 4x. But I have to add on this number 2, right? I've got this one here. Well, let's do the math. If this was 5x and this was 4x, obviously it's just 1x, or you could just write it as 1, right? Times 3x plus 1. So we have to add this together, but first we have to distribute. So plus 3x squared plus, and I'm going to drop the 1 and just say plus x. So now collect like terms. This is what we've been learning all year long. I've got an x squared here and I've got an x squared here. So 28 plus 3 is 31, x squared, and I've got 4x and another x plus 5x. Do I have that? Let's see. I do. Next page. Oh, now, some of you maybe didn't get to the coding unit. Some of you, and that's okay, all right, because it makes sense. Basically, coding is exactly like math because you're procedurally working it out line by line. So pseudocode, if you don't know what this word pseudocode is, if you didn't get the chance to do the coding unit, maybe you're behind, that is just basically like in words what the program is going to do. So that's all you're really, it's like the word program instructions. That's what pseudocode is. And you know what? It's the same thing when we write out a word problems, right? And I say to you, show me the work, show me the work. So let's have a look. The pseudocode will be used to determine the hypotenuse. Ooh, and you should all know what that is. The hypotenuse of a right angle if the user inputs the lengths of the other 2 sides. All right. So we have a right angle triangle. We're going to input A, we're going to input B, and they're going to give us C, right? Basically, that's what's happening here. So a line is missing in the pseudocode. Okay. So side A, remember, this is like a variable that we would have said like, let side A equals let side B. This is like resetting it, right? So you don't even have to really worry what's going on here. That's just resetting the code. So now the screen output, the screen is going to say, enter the value of side A. And then the computer is going to say, store the user input. So whatever they put in, whatever they type in the keyboard, it's going to be stored in this variable called side A. Then it's going to say on the screen output, enter the value of side B. And then store the user input of side B. So now the computer has something sitting. They're not zeros anymore. Now we have side A and side B. So now, it has to do something before then it says the length of the hypotenuse is. Well, it obviously has to do the math. It hasn't done any math yet. It's inputted. It's like it has this box called side A, and it has a number in there. Maybe it has a number 7. And then it has a box, and it's called side B, because that's kind of what variables are. They're just like temporary placeholders. And maybe the side B is 3. And now it has to figure out, what C is. So where are we going to figure out the math? Well, it's going to have another variable called hypotenuse. Well, we know, is it the square root of side A minus side B? Is it like, how do you figure it out? Well, you know what the formula is when it's always, right? C squared equals A squared plus B squared. You know that's what it is. This long side, the one that's always across from the 90 degrees, is called your hypotenuse. And it's just these 2 numbers squared together, added, and then you take the square root of it. So now we have to figure out, well, which one of these would actually be represented by that. So it's definitely not going to be just side A minus side B. No, that's definitely not going to work, right? Is the hypotenuse side A plus side B? No. The square root of it? No. Is it side A times side A? Oh, so that's kind of like side A times side A minus? No, of course not. Aha! It's side A times side A, which is basically like saying A squared, and side B times side B, which is basically like saying B squared, right? Added together. So it's definitely going to be D. So here's an example, and they might also say to you something like, how many variables are in this? And you're like, well, I have a side A, I have a side B, and then I would have set up another variable called hypotenuse, and then the answer, would have gone in there. Okay, let's keep going. Pseudocode. Again, pseudocode is written when you are just figuring out what you want this program to say and to do. 2 lines are missing, okay? So be careful. 2 lines we got to do this time. Okay, so number A, we're just resetting these. This is basically so you can just do the program over and over, right? That's just saying the variables, these boxes that we have, and one is called number A, and the other box is called number B. They're just empty. Like we got a 0 in them right now because we got to make sure we start at 0. Output, enter the first number. So now we have to store it, right? Like the computer has to put something in this box. So let's see what we could say that would store number A. Well, obviously, store A has to go into here, right? If you are entering the first one, you would want to say store user input, like whatever I typed in my keyboard, as number A. Put it in this box, whatever. Maybe I put the number 27 in there. I don't know. Whatever, right? It doesn't matter. It's whatever I type in the keyboard is now going to go in this variable, in this temporary placeholder. Output, enter the second number. Store user input as number B. Okay, kind of like the exact same thing. If, now we have an if, like a condition that's happening. If something, output, the sum of 2 numbers is 8. Okay, well, let's think. What could they want us to do? Else, output, the sum of 2 numbers is not 8. Okay. So now let me think. How do I know it's going to be one of these or not? Am I going to store the user input at this point? No, I'm not storing anything. I want the computer to do it, right? I want the computer to do whatever they've typed in. So it's definitely not going to be that. It's going to be one of these mathy things. But the whole point is that 2 numbers, if you add them together, they have to equal 8. So which one here is adding equals 8? Look, adding equals 8. Right? It's E. E is going to go in your second box. Okay, so again, don't panic when you see these pseudocode questions. Just think to yourself, you're kind of setting these boxes up in setting up the variables. You're resetting them. You're telling the computer, enter something in, store it in there, enter something in, store it in there, do some math, right? And then if it is number A plus number B equals 8, then I want you to say the sum of the 2 numbers is 8. Else, say the sum of the 2 numbers is not 8. All right, so this is a little bit harder because it has an if-then statement, but it's all logical. It's very, very, coding is just math logic. All right, now we look at this one, and we've done a lot of these different XY table graphs and charts. Represent and compare linear and nonlinear. Okay, so your brain, linear, you should remember it's like a constant increase or decrease. Nonlinear, right? It's not constant. Like it could go up by crazy amounts all over the time, right? We don't know. So if we look here, we have to ask ourselves, is this going up by the same amount? 0 to 1.5, if we did our first differences, we can easily see it's going up by 1.5. 3 to 1.5. Remember how we did our first differences this way? It doesn't really matter. I can clearly see that it's always going up by 1.5. Look, 1.5, 3, 4.5. I'm going up by 1.5. So definitely, This is a linear relationship. The rate of change is the same, right? That's a linear relationship. It's going to have a positive slope. The line's going to look like that. If the object travels at a constant rate of change, what distance does it travel in 5 seconds? Well, all you're going to have to do is do 5 times the rate of change. And again, here's the good news with EQAO. There's a little calculator built in, but don't even, I mean, I can do it in my head, but I'm just showing you. 1.5, 7.5. Bingo. Okay, next question. Demonstrate an understanding of the characteristics of various representations of linear and nonlinear relations using tools including coding when appropriate. Which line has a slope of -4/5 and a y-intercept of 6? Now your brain, you've done a lot of this. Your brain should instantly know when you see the y-intercept of 6. This is the point where the 6 and the line crosses at 6. Does it cross at 6 here? Yes. This is still a possibility. Does it cross at 6 here? Yes. This is still a possibility. Does it cross at 6 here? No. This is not a possibility anymore. It does not cross at 6. Does it cross at 6 here? No. This is not a possibility. Okay, so these two are off the chopping block. Now we have to look and go, okay, and it has a slope of -4/5. Well, I can tell that they both have downward slopes. I can see that they're both lines going down, so I know it's a downward slope, and I can see that because it has a negative. So remember, slope is rise over run. So it's going to go down 4 and over 5. Let's find which one it does. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. Clearly. Okay, that one was not right. This was the one with the slope. And you should know that. That question should not freak you out. Last one, and I'm going to stop this video because each EQAO sections are about 14 questions long. So I'm just going to give a pause after this one, but let's do this one together. So we have now a table showing the relationship between the amount of water in a pool in liters. Oh, this, you got to be so careful. You got to be so careful because they're going to do this to you. They're going to like ask you to put the answer in different units and stuff. Like they'll go kilometers or kiloliters and kilometer. They'll change it all up. So be careful about this. Okay. Be careful, be careful, be careful. The pool is being emptied at a constant rate. All right. So we have 0, 60,000, 10, 55,000. So right away in your mind, the first thing you should do is figure out the difference. And I can see that it's going down 5,000 in 10 minutes. Now let's see if that's true. 20 minutes, I go from 50 to 55. Yeah, that's the same. Oh, careful. Look what they did here. They threw a 40 in. They skipped the 30. And it went down 10,000, but in 20 minutes. So it's exactly the same. 10,000 in 20 minutes is the same as 5,000 in 10 minutes. And I'm going to make it even easier. And I'm going to say 5,000 in 10 minutes is actually equal to 500 a minute, right? Again, I like to make my life easy. So now I know, okay, I can drain that water out of that pool at 500 liters per minute. So now it's saying to me, how much time does it empty the whole pool? Okay, well, the whole pool is 60,000 liters. And I know it takes me 500. So 60,000 divided by 500, you know you can always cancel out zeros to make your life easier. So I go 600 divided by 5 is 120. It is 120 minutes. All right, that's video number 1. And that's long enough.